backup and recovery. In order to fully understand the backup and recovery schemes and methodologies in SUSE Linux, we need to talk about Snapper, as it encompasses the majority of the predefined backup profile for a SUSE Linux box. Let's talk about what Snapper is first, because you may not have seen it before. Snapper is a tool that provides, given the right circumstances, the ability to perform rollbacks of individual files or an entire subvolume or file system. Now, there are some prerequisites for this. The Better or ButterFS file system is the recommended version that we would like you to use, or file system to use, on a SUSE Linux box if you're going to be using Snapper. Although you can use LVM with thin provisioned logical volumes if you so choose. Also, you do need SUSE Linux Enterprise 12 and newer in order to do a boot from snapshot function, which allows you during the boot menu to select a previous version of a volume and use that as your boot volume. So what's included in a snapshot? Well, the root file system by default is included, but there are some directories that are not included, both for practical and technological reasons. The first and the biggest subset, if you look through here, are things that you're probably not going to want the constantly changing information inside of those directories to be captured every time. As a result, those are removed from the snapshot. Now, you can go and configure this to include these directories if you want to. This is only the default settings. Feel free to customize as you need to. So, what are the types of snapshots? Well, there's a timeline, which is turned off by default for root. It's taken hourly. That's what a timeline is. And the last 10 daily, monthly, and yearly snapshots that are part of a timeline are kept. Again, this is disabled by default, but can be turned on as necessary if you need periodic ones. There's software management types of snapshots. When you invoke the libzip library when doing software management, the zipper command or inside of the software management tools found in YAST, it creates a before change and after change. We call those a pre and post pair. Those allow us to roll back should a software install go awry or not have the desired effect. Anytime you go into YAST, you also, and open a module, it will create a pre and post pair as well. This is, again, so that before the change and immediately after a change that you implement through the YAST modules, those will be preserved. So you can have a rollback or a backup plan or method if necessary. We can also trigger a manual snapshot as well from the command line or through the tools available through YAST. So let's talk about the configuration of Snapper itself. In the etc directory, there is a Snapper subdirectory with a configs subdirectory of that. If you were to use various tools, the Snapper tool from the command line is listed here with the create-config and the path you want to create a configuration for, it will generate one for you. We can also list the configuration options there as well, and there is an example for the root volume. We can get a list of Snapper configuration files if we look inside of the etc sysconfig snapper file. And if you want to prevent a file from being snapshotted, you can also go and filter those files as well. Here's an example of what a configuration file looks like under etc snapper. If we look at this one, which is described for the root volume, you'll see that it has different types of things, and they've been broken up into colors here to make it a little more obvious. We have user permissions, those who are allowed to work with snapshots and the configurations. We have the number, so how many snapshots should we keep? We'd call those snapshot parameters. We have timelines, which are time-based snapshot configurations. And of course, we have the pre and post snapshot configuration items as well. So what tools do we use for managing snapshots? Well, inside of YAST, there is a Snapshot Explorer that allows you to view differences between files, to create new snapshots, to view existing snapshots, and of course to work with all of the various components that come from maybe restoring an individual file or an entire volume as well. There's also from the command line a tool called Snapper that allows you to show, create, or delete snapshots and do rollbacks. You can also do differentials of files and see the differences between them. But also, the configurations and information about snapshots are kept in a quote-unquote hidden directory underneath each location where a snapshot directory or configuration is defined. Under the root volume, by default, it's the .snapshots directory immediately off the root volume. Inside of it, it has a list of directories that each one will represent a snapshot, and it will contain things like a descriptor of the files that have changed and other information that can be read and worked with directly or through these various tools that we've already talked about. Here is the YaST Snapper module itself. As you can see, we have various snapshots. They're defined by their IDs. That's on the left-hand side. These IDs simply are unique identifiers that we use either from the command line or identifiers that we could use here to say exactly which one came from what time period. They're a little simpler than putting in a date. Now we can highlight one, we can look at things inside of it, we can make some changes to the snapshots, and various other things noticed down at the bottom in the buttons. In this particular part, we've gone into a snapshot and we're comparing the differences between two files from the same file from two different snapshots. You can see in the red with dash 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 in front of it in the right-hand box, you can see that something has changed. This is the modify date for the time for that file, and then plus plus plus, which says this is what was added or modified. And then you can follow that same logic down below where we see the history and the last visited are being removed, but then we see the history and last visited being added with different values. This is indicative or typical of these kinds of changes that are made and captured via snapshots. And the Snapper module makes it very easy to display. Now, if we want to, we can also restore a file from a snapshot. So we've configured, let's say we've found this file to be what we want. We select, yes, we want to restore it. You can do that in the bottom right-hand side. And you notice you can restore the file. You can restore from the original. You can restore from the second one. And it will pop up and give you a, are you sure this is the one you want? If you click yes, it will restore the file as you described. We can also, inside of the YaST Snapper module, create new snapshots. We click Create New Snapshot button, and we add a description, the type of snapshot it is, whether it's associated with another snapshot in pre and post format, and then we can give it some additional information about its cleanup and so forth. If we want to modify a snapshot, let's say we make a change, but the built-in description is too plain, we might come in and say YaST security -password or something like that to say we've made a change to the way that passwords are handled and this is the one after or before that change, whichever parameter you want to capture or remember as part of the description. Now the Snapper command does pretty much the same things that are found inside of the Snapper module. However, it's from the command line, so it requires the standard format and layout for both arguments and parameters. So the general Snapper syntax is Snapper, any global options, the subcommand or the command options that go with it, and any arguments that go with it. So as an example, a simple one, Snapper space list, would list the snapshots for the root file system, unless of course you specify a particular volume other than root. By default here, it's going to be the root volume. To create a new snapshot, we would do a Snapper create, -D put in a description, -T the type of snapshot, whether a pre or post number is going to be involved, and then the command for additional items if you want to. Here's an example down at the bottom. Snapper -C SRV, create -D, description -C timeline. There we have an example of a snapshot being created of type timeline. Now, there are a bunch of other things that we can do with Snapper besides simply creating snapshots. We can do a compare of snapshots, Snapper space status, and then two different snapshots, and it will give us a list of files. that have changed. We can look at the contents of files using the diff snapper command, snapper space diff space the number of the snapshot, that's the ID, dot dot, the other one you want to compare it to, and then a space and the list of file or files you want to compare. We can undo a change on a file with snapper space undo change space, and again, the ID dot 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 ID, and then the file you want to undo or to roll back. We can delete a snapshot by using the snapper-c config, whichever configuration we're going to be using, delete, and then any snapshots you want to remove. Yes, you can use a range, as is noted in the command here. Now, snapper commands that we might work with also things like snapper get config to tell you how a particular volume or subset of volumes is being snapshotted. We can change the configuration from one value to another with a snapper-c config and a set config value, or we can use a create configuration as well. Now, working with snapshots, and we've described the YAST tool and the command line tool, there's also a directory layout that we can work with. Again, it's usually at the root of the volume where snapshots exist, in this case, the root volume. If you look at the info.xml file, as is highlighted here, you can see information that describes the snapshot. We can then go into other snapshots, let's say the number 2 snapshot, and we can see any files and directories that have been modified or worked with, and so forth. This becomes easy to work with as well as you familiarize yourself with those directory structures and what each of those files contains. Now, having created snapshots and looked at different things, what about rolling back a change? Well, there's a couple of different ways to do this, and it depends on if you are working with a specific snapshot you want to roll back to, or you don't provide one. The simple syntax is snapper space rollback, and then the number you want to go back to. And it creates 2 new snapshots and sets the default subvolume. So per default, the system boots from the default subvolume for the root file system. And the exact actions of this snapper rollback number command depend on whether a number is provided or not. If you do not provide a number, first a read-only snapshot of the default subvolume is created. A second read-write snapshot of the current system is created to preserve your current location, and then the system is set to boot from that snapshot. Now, this is useful if you choose to boot SLE, SUSE Linux Enterprise, from a read-only snapshot in the boot menu and want to make the system boot from this snapshot by default from now on. If you provide a number with the snapshot rollback number command, a read-only snapshot is created of the current system. A second read-write snapshot is created of the numbered snapshot, and the system is set to boot from the second snapshot. Now, this is only supported with Btrfs and requires a properly configured system, and by default, this is how SUSE Linux Enterprise is set up when you install. Let's talk a little bit about the mechanics of the rollback itself, and maybe a visualization will help. Before any rollback, this is what it looks like. We have various read-only snapshots, and we have a current read-write snapshot. In other words, the way the file system currently sits. If we issue a snapper rollback 2, read-only 2 being the target rollback that we're going for, the first thing that happens is that a new read-only clone is created. This one is, in this case, going to be called read-only 5. This is a capture of where we currently are in case we need to back out. We then take and do a new read-write clone based on the number that was given, number 2. The new read-write clone is then defined as the Btrfs subvolume default, so that the next time that we work with it, that's the subvolume that we'll be working with, that particular version. Then a new clone is created just to make sure that we haven't, so we've got a back out point from before the change and after the change as well, so we can recover to a certain point. To boot from a snapshot from the command line, and this is SUSE Linux Enterprise 12 displayed here, but works for anything after SUSE Linux Enterprise Server 12. If the system does not boot properly, we can select from the menu, start the bootloader from a read-only snapshot, select the one that we want, and boot the system accordingly.